Hi, this is our presentation for our senior project presentation for senior project class ET 421 at New Mexico State University. Our presentation today is going to be about photogrammetry. My name is Mario Marquina, and with work with Billy Llewellyn, we present this to our professor Ahmed Elakshir. The area of concern for our project would be located north of Albuquerque, New Mexico, and south of Santa Fe, New Mexico, in the city of Rio Rancho. Okay, to start off, the way we did the survey on this piece of land was we first had to set out some parameters and coordinates to be used in this area. And all this was based on the coordinate grid system that's used for New Mexico. And basically, a coordinate grid system provides a unique reference to each location on the Earth, all based mainly on northing and eastings and or latitudes or longitudes. Again, based on the project area of concern, utilize the New Mexico State Plain Central US Survey feet, which is the NAT 83 coordinate system. Okay, for a designated area, we found we use this lot that is approximately a half an acre, 0.53 acres of area. Okay, back to our project. The main idea of this project was to use photogrammetry, which uses the principles of photogrammetry are based on triangulation, or more specifically called aerial triangulation. The way this is done is by taking photographs from at least two different locations, so-called lines of sight, that can be developed from a camera to points on the object, such as a target control point. The way we set up our aerial control points was by using these targets that you could see right here. These target control points or ground control points are placed on the ground that have precise, and they have precise known locations associated with them. This including northing and easting and an elevation. So in each one of these targets that we laid out throughout the land parcel area, each one has a known northing, easting, and elevation to it. This in the idea to tie down all photogrammic imagery and to like mesh it together so that all images have a reference point of elevation, and from that to determine a three-dimensional model that could be used as a surface. Now, in order to set up our control targets, we used what is known as a total station, which is an instrument that uses electronic theodolite in practice with an electronic distance reader. And to set up this total station, the use of a marked point of reference was established based on the stated coordinate system. Again, referencing to that grid system that we established before everything. And based on this, we set up two known point elevations, and based on these two reference points, we used them to triangulate to the total station and use those as reference in order to set out new shots on whatever part of our parcel land area we used. Meaning from this reference, we created a whole new surface using just the total station. This is a CAD drawing example that we had as an outcome from the use of the total station. And right here, you see we took a couple of shots. Each red point is a shot that, again, contains northing, easting, and elevation. And from all those shots, we derived a surface, an existing surface. Now, coming back to the drone use, or the what's known unmanned aircraft system or unmanned aircraft vehicle, such as this drone. This is what we use to take imagery. The parameters used on this drone were approximately 200 feet in height. And we made sure that the images taken had a approximately 40% to 60% overlap within each other, so that we can make sure that it has enough surface area on each image to be able to gather all the data needed to create a three-dimensional surface off of this drone. The drone used, known as a Phantom 4 RTK FGI drone. Again, more information on this drone and specifics about it are provided on the technical report with this presentation. And again, here you see a couple of parameters and specifics of this drone. Okay, on this slide, we show the final outcome of the surface from the drone, meaning that we took all these images that the drone shot, mush them together by the assistance of some automated software, and we mush them all together and referencing our area control points that you could kind of see from right here. Again, more information and detail about this is provided on the technical report. And using those targets as reference to elevation and horizontal and vertical reference, we were able to create a three-dimensional surface. And from this, we took the contours, which you could see right here, kind of very detailed. And something very specific on this image is that the purple or magenta and red contours are from the drone surface. And what you could see as yellow and green contours are from the total station shots that we took, which is the other existing surface, but from the total station. And right here, you could see a difference in contouring, and the idea that the drone surface, magenta and red, are more detailed than the green and yellow surface from the total station. This is a cross section that was taken from in that same area of concern. And it includes the existing grade from the total station and the existing grade from the unmanned aerial vehicle or from the drone. And you can see they're relatively close, but the existing total station gives a more precise or accurate determination of the surface, whether in contrast to the unmanned aerial vehicle that gives a more detailed, but a little, in some places, it seems like it's lower or higher than the total station surface. Now, coming back to this cross section, you could see the difference in a little bit the difference in elevation from both existing grade surfaces. And then on this slide, we created what is known as a tin volume surface, which basically indicates or kind of color codes the areas in difference of elevation from one surface to another, which is basically as it's the blue and darker blues colors that you see right here. And the darker the blue gets, the maximum elevation in difference it is. And then in contrast, whether the less blue you see is or the lighter blue you see is the minimum elevation or a cut towards each in difference of each surface. Again, from that, we derive a cut and fill report, which in conclusion gives us just shows us the area covered by this surface, the total cut, the total fill, and the net, which in results was 523.76 cubic yards of cut. And this concluding that the drone surface was a little bit less accurate than the total station surface, reflects the NAT 83 coordinate system in New Mexico. So that's our result on that one. Thank you. As well, I want to share with you guys a couple of procedures we followed, or kind of like indicators of that we use for this project. And I want to come back to this vicinity map, which again shows you kind of the area that we worked in and the parcel where it's located. And from this, we carried out, we kind of did what would be really close to a Plat survey, and which basically indicates our coordinate system, what we established, our reference points, our found elevations out there, corner properties, just to determine the boundaries and the area we are working on. Again, from this, if you remember how I explained using the total station, we took a couple of shots, well, quite a bit of shots from that area that we used to determine the surface from that total station. And this is what we derived from that information. We got a point with, of course, a point number, northing, easting, an elevation, and the description at the end on the table you see right here. And that's what makes up our surface from the total station shots. Coming back from this, we see again a plan view of our surface, but now we created sample lines in order to show what happens within those cross sections, like where our surface elevation is in comparison to the plan view. This kind of demonstrates how we set out our aerial photo target references. And they're based on the area of the parcel used or the area of concern. We determined 4 area control points we needed based on the area we needed to cover. And even so, we may have gone a little bit more than what we needed just to make sure. But you could see images of the area control points set out, and beneath the images, you see the area control points data, which again shows the point number, northing, easting, elevation, and description. Now, all this information of the images are tied down to these control points. So all those images are referenced to these control points. And then to the left, you could see a plan view of the area and kind of where we set out the 4 control points. Now, having determined those control points and meshing all those images together and referencing those control points, we derived this 3-dimensional surface of the area. Again, it's one of the, you can see it's more detailed than the total station area, since it may pick up more contouring in the area of the land. And we see as well a couple of cross sections of those, which you could see it picks up more details within them. Yet again, coming to this, the idea of having more detail not necessarily means that, or from my understanding, means that you're more closer if you don't have correct reference on those control points or correct reference to real elevations. So it's very important for those to have those control points and have them indicate or referencing the correct elevation for all your images. On this slide, we show the comparison of the 2 surfaces from the total station and from the drone images that we got. And again, you could see how the contours of the total station are a little smoother than the contours of the unmanned the drone. And then to your left, you could see the cross sections as well, but now it indicates both of the surfaces, and you could see the comparison to them. I mean, they're relatively close, but there's still more precision in the total station. On this slide, it takes a little bit to load. There's a lot of information. Coming back to that again, we displayed a volume tin surface that generated us our cut and fill report. And in this one, you could just see the contrast between the 2 elevations and how much deeper one is in comparison to the other. Again, showing that they're not exactly the same. And in conclusion, the drone surface is less precise than the total station surface. Finally, I would just scroll down, showing you some images taken by the drone around that area that we used again for this for these surface, three-dimensional surfaces. And as well, I would show you finally some images taken of us during the work we did out there. Thank you very much for your attention. Goodbye.